When Raspberry Pi announced their new microcontroller, the Raspberry Pi Pico, based around the RP2040 that they designed, they also said that they were going to make the microcontroller available to other manufacturers. And they also mentioned at the time that one of those was Arduino, which was planning to make their own microcontroller board based around the RP2040. And that's now available. So in this video, I'm going to take a look at the new Arduino Nano RP2040 Connect. Going to look at an unboxing, have a look what's inside, and some of the features versus the cost, and going to have a look at setting this up using the Arduino IDE. Now, I think this is quite a looked forward to version of the RP2040 because of the brand name of Arduino and their support for the community and their open source hardware designs. So all the details of that are available on their website, including the schematics and everything else you need to understand how the board works. You can start by unboxing this, or have a look at the box first. So specifically, this is the Arduino Nano RP2040 Connect with headers. So the headers are already soldered onto this. At the moment, that seems to be the only one that's available. Perhaps in future they'll provide one without headers as well. So it's usual Arduino branded box. And just have a look through some of the features that are listed. Connectivity, Wi-Fi and BLE, Bluetooth Low Energy. And that's based around the ESP32 microcontroller, which I've covered in an earlier video. You can find more about that on there. The chip is the RP2040, and that's a dual core ARM Cortex M0 Plus, and quite relevant, it says that small, powerful, connected to the power of 2. Not sure whether the power of 2 is the combination of the RP2040 and the ESP32, or I suspect it may be because of the dual core in the processor, but yeah, either case. Clocked at 133 megahertz. Memory, which is 16 megabytes of flash memory, which is a significant increase compared to the Raspberry Pi Pico. 264 kilobytes of SRAM, which is actually on the chip, so that's going to be the standard for all RP2040 based boards. Interfaces, it lists USB, SPI, I2C, I2S, PIO and UART. And there's also some additional features on the board built in, which we'll cover as well. Voltages, it's 5 volts through the USB input. Oops. It's 4.5 to 21 volts through input V in. That range actually sounds like really useful because the upper end 21 volts is probably going to be quite useful for those looking to integrate these or use these on model railways, which typically work around 19-20 volts. But the chip itself runs at 3.3 volts, and that's very important. You need to remember that anything that connects to the pins on any of the boards designed around the RP2040, it's not 5 volt tolerant. You need to make sure that you only use 3.3 volts inputs and use that 3.3 volt output, say through a MOSFET if you need to drive larger loads. Pin out, 22 digital pins, 20 of which have got PWM and 8 analog inputs as well. And it's got the dimensions on, which is 18 by 45 millimeters. Now this is the first time I actually had one of the Arduino Nanos. I know these have been around a while, in other forms, but this is the first time I've got a Nano. I've been looking at the other series before. So it has just arrived. The sticker on the top is quite secure, but the sticker on the bottom is actually not stuck down that well. Just makes it easier to open. Now we can take a look. And wow, that is really tiny. So that's a significant step down from the other Arduinos I've got. Of course, it comes with the Arduino stickers and some basic warranty information. But if you want any of the information on how to actually use this, then you need to look on the Arduino website. So I think it'd be useful at this stage just to compare this to some of the other processors that are boards that come along. In particular, so this isn't the first manufacturer to use the RP2040. Of course, you've got the original Pico from the Raspberry Pi, significantly bigger, has got more pins on, but is quite a lot bigger, and there's a lot more empty space on the board on that one. And I've got another board, which is the Tiny 2040, which is by Pimoroni, and see, that one is actually even smaller still. Significantly, the Pimoroni one has a USB-C, whereas the others have micro USB, and basically it's the same width factor, but it's a lot shorter. But this is a lot more limited, as it's basically just the bare processor or microcontroller, and with only a few pins available. But if that meets your needs, that's quite a nice little tiny solution. In terms of price, the Pico is definitely the cheapest by a significant amount. I think roughly about £4 or £5 for one of those. The Tiny comes in about double that, and I think partly that's due to the lack of manufacturing in bulk that the Pico does. Obviously, their Picos scaled up quite significantly, and they're able to do that quite cheaply. Also, it's double-sided, the Tiny is, so that probably increases the costs as well. And unfortunately, the one downside about the Arduino is that really the cost of the other two pales into insignificance compared to this one, which is about £20 odd, I think, just for the board. However, saying that, you do get a lot of features that are not included in the other boards. So this, I think it's a U-block, it's called, is basically a ESP32 microcontroller with the Wi-Fi and Bluetooth low energy on there. You see you've got the RP2040, the main chip in there, and then the next biggest one is going to be the memory, which is 16 megabytes, which is so significant. I think it's about 8 times the size of the memory on the other boards. You've also got an accelerometer, you've got a microphone, and I think there may be a couple of other features, but basically this is a well packed in high-end fully featured microcontroller, comparable with a lot of the other Arduinos, putting it in a different league. So if you want basic cheap microcontroller, then the Pico or the Tiny may be able to do your job, but if you're really wanting fully featured microcontroller, then the Arduino has got plenty of features in there. The thing I noticed while I'm turning it over, so it's got numbering on the pins, but they're not very easy to read compared to the Pico. The Pico, they're sideways on, giving you plenty of space to put the write in. On the Arduino Nano, they're really quite scrunched up. You can just about read them. So as well as comparing it against the other RP2040s, let's compare it against a Raspberry Pi Zero. As you can see, the Arduino RP2040 is considerably smaller than the Raspberry Pi Zero, although the Raspberry Pi Zero is a fully featured computer rather than a microcontroller based board, which is what the Arduino is. And we move all these out the way, we can take a look at compared to the other form factors of the Arduino. So I've got two different ones here. So this is the sort of classic Arduino shape and size. This is actually the UNO Wifi, so this is a more modern version of this, and it has got the same U-block Wi-Fi on here. It's got a modern process microcontroller, but it is fully compatible with the original 18 mega, say 168, 328 processors, but it has got a lot more functionality on that. Fits the original hats, so if you're into the Arduino, sorry, hat is a Raspberry Pi word, I mean the shields. So Raspberry Pi referred to theirs as hats, Arduino, they're the shields, so that still fits the original shields. This is the newer MKR or Maker series, and this is the Maker, I think it's the 1010 Maker Wi-Fi, yeah. So this has got the Wi-Fi built in as well. Again, the same U-block, all three are using. And this is the smaller form factor. You can get the Maker shields that fit on top of these. And the Nano just takes it much, much smaller. And obviously there's some downsides. You can't put shields on top of those. If you want to connect onto that, then you need to put it onto a breadboard or to solder it into your own circuits, which is possible thanks to the castellation of the pins if there weren't headers on. So that's one of the things. So it specifically came with headers, and it said it came with headers. Imagine in future there's probably ones with no headers that you can then solder on direct onto a circuit. So one more thing I want to show is how well this fits on a breadboard. If you saw my previous video on the ESP32 development board, you'll see that I had to use two breadboards because the spacing wasn't very well, didn't leave many pins left. But as you can see, this one pops onto is designed to go onto a breadboard. We go for that, fits in very easily. I mean, these are cheap breadboards, they need a bit of force to plug them in. But as you can see, it uses 2 pins on one side and 3 on the other. So that gives you 2 full rows of pins available on one and 3 available on the other. So plenty of room and really good for breadboarding. The one more thing I'm going to do is just try and power this up as it comes out of the packet. So this comes with the default demo program rather than anything that I've created, and let's just look. So as you can see, it's got some flashing LEDs. So the green LED is the power LED. The flashing orange LED is the standard inbuilt LED, and then there's an RGB LED as well. So this is just a standard RGB LED, I believe, with 3 LEDs in one package. It's not like an NeoPixel or anything like that, it's just a standard LED. I understand that's connected from the ESP32 rather than directly onto the RP2040, so you need to use that to activate that. But that's showing some of the features that are available. So the next step is to plug this into a PC, set up the Arduino IDE and have a go at programming it. I'm going to be plugging this into a Raspberry Pi and demonstrating it on there. Take a look at that next. I'm now going to show how to get started using the IDE on a Raspberry Pi. This will be the same process on other Linux computers, and it's similar for Windows and Mac OS, but there is one step that you should be able to skip for Windows at least. The Arduino IDE is already installed on this computer. I already set it up for the ESP32 example that I used previously, but I'll still show you how you would set it up. So although there is a version of Arduino IDE in the repositories, it's an older version and I recommend you get a fairly recent version. The version I'll be using is Arduino IDE 1.8.15, which is the current production version. And for the Raspberry Pi running the standard Raspberry Pi OS, you need the 32-bit version, so Linux 32-bit. You click download that. I've already done that. In my case, I like to save it in the opt directory, so cd/opt. To install it here you do need to be root, so it would be sudo, and tar is X to extract, J, capital J, because it's an XZ file, and F for the file name, and then the file you downloaded. Mine goes into /downloads, and then this is the file that I've already downloaded. That won't run that because it's already installed in this Arduino directory here. You can set this up then to use the start menu, but I just leave it in there. So to launch it, I'll change back to my home directory, just type /op/Arduino. I'm using tab completion to save me typing all this out, and then Arduino. Now we need to add the board to the IDE, and you do that by going to Tools, Board, and then the Boards Manager. Let's get rid of that behind, and you can search for the board that you want. Actually, it's shown here, Arduino Embed OS Nano boards, but the easiest way to find it is just to search for RP2040, and you see that there's the Arduino Nano RP2040 Connect in here. There's this one as well, which is for the Pico, so they've added support for the Pico now, but this is the one we particularly want. Latest version 2.1.0, just click install, and that's going to download then. So that's finished installing. Just a word of warning, I did skip through a lot of that there. It did take quite some time to install, over 10 minutes. So good time to grab a cup of tea or coffee, particularly when it was installing the tool chain. Step 3 of 5, I think it was. It just appeared to hang for several minutes, and just need to be patient with that. So now that's installed, we should be able to find it. However, as I discovered when I installed this on my laptop, there's a script that needs to run, the post install script, and that needs to be run as root. So it needs to have the sufficient permissions to update the UDEV rules for the operating system. Presumably because of that, it's not actually been able to run it as part of this install. So it is a command you need to run afterwards on a Linux system, including, I presume, the Raspberry Pi. So I'm just going to close this. It's not very difficult, but it does need a bit of navigating to find it. And the first thing is it's in the home/pi/.arduino15. So this is the directory for version 1.5 of the Arduino, but to keep it compatible, they've maintained that numbering for the future versions. If you're using the newer version 2, then that may change. I don't really know. I haven't used that because it's only in beta at the moment. Then into packages, you see we've got the Arduino folder here, hardware, embed Nano, which is the RP2040 type, and then the version number 2.1.0, and you'll see here there should be a post install.shell file. There is also a .bat file if you're finding you're having this problem on Windows, but I don't think it has that problem on the Windows. I think it's just on Linux. So I just need to run this as root. So one thing you can do is you go to Tools and Open Current Folder in Terminal. I'll just increase the size of the terminal so that you can see. And you can see in here the post install.sh file, and you just need to do sudo /post install.sh. That's now updated the rules, so that's it. But it is a bit of a bug. If you're trying to just run this, then you do need to know about this extra step. Now that's done, we could just close that, go back to my previous window and relaunch /op/Arduino. So now we can plug the Arduino Nano RP2040 into the USB port. And if we now go to Tools, Boards, we should be able to find it under the Embed OS Nano boards, and it's here, the RP2040 Connect. And the port, and as you can see, it's detected the port. It's on TTY ACM0, and it's labelled it to say that that's it. To test this works, we'll use the traditional, most simple example available, which is the blink. So examples, basics, blink. Get rid of the other window, we'll get rid of that. And if we just click on the upload, then hopefully this should just work and install. So let's see if this goes. So that's finished. It says done uploading, no error messages, and the LED is now flashing. So this hasn't touched the RGB LED, which has now gone off, and it's just blinking the orange built-in LED. So that was a very basic demonstration. I'd like to just use another demonstration to show you the Wi-Fi capability. As really, if all you're doing is blinking the LED, that's a bit of a waste of this pretty impressive board. So we're going to look at one of the examples that Arduino provide, which is to set it up as a web server on its own private network. So it's going to create it as a wireless access point so that you can connect to it, say with your phone, access a web page on it, and change the RGB LEDs. So this has got quite a few different features in that we're going to see. We're going to create a new one. I'm just going to copy in here the code taken directly from the Arduino website tutorial. As you can see, it's going to set up a network called your network, and with your password. Obviously this is a very insecure network. We're going to use this for a demonstration, but I wouldn't leave this on that afterwards. And it's going to refer to the three colours of this one LED as three separate pins: LED R, LED G and LED B. Now, one thing to be aware of is for these to work, you specifically need this Wi-Fi Nino.h in. That's needed both for the wireless capability. Obviously it's the Wi-Fi Nino W102 that's used for the Wi-Fi, but also that RGB LED is actually connected to that. It's not connected to the RP2040. So as long as you include that, then it's going to import them and it's going to access it through that because it's included in the supplied libraries. I'm going to use serial port for messaging us so that we can see what's happening. We're going to create an access point. It's already created a web server and it's going to set the server running. And we can just sort of go through this. So this is when there's a client's connected, and you'll see this is very similar to the ESP32 code that I used in my previous video. If you want to look at that and compare that, some of the function names are different, but very similar. This is creating a web page, and this is turning the LEDs on and off as they're clicked. So we can just push that to the board. I'll just call it RGB Wi-Fi as an example. Okay, so it's immediately failed with Wi-Fi Nino.h missing. I thought that would have been installed when we installed the hardware, but we can go and have a look at the installed software libraries. So just filter that on Wi-Fi Nino. So this is the library that we need to install. Make sure we got the version that's compatible, so just take the latest version there and we'll just install that. Okay, so let's close this and we can try again. So that's uploaded, and now I need to go onto my phone, and if I search for the network, hopefully I should be able to see. I can't actually see it at the moment, so let's just have a look in the serial monitor, because remember I said that it's put in details to the serial monitor. So it says creating the access point. Right, so it has connected. I think it needed the Wi-Fi, the serial port connection. Of course, if you finish building it, you can just remove all these references to the serial port, and then it'll run standalone, but these have been included for debugging. So click on your network and it asks for the password, and the password is your password. You do need to make sure you haven't got something like Smart Network Select on your phone. Mine's reporting no internet connection, which is correct. And then we need to plug in the IP address, which by default is 192.168.4.1. So I've now got 6 buttons. The red, green and blue, I've got on buttons on the left and off buttons on the right. So if I say turn the red on, turn the green off. So as you can see, each time I press a button, it flashes up on the screen what the request is, and it's changing which LEDs are turned on and off. So I just think that's quite a nice little example of how to use that. It's very similar to the ESP32 example I used previously, although in that case I didn't set it up as an access mode. I actually had it connect to my own home internet connection, whereas this one's a standalone connection. So these examples that I've shown have all been based around C/C++, which is the native language used by Arduino and the RP2040. I do like the idea of using Python on the RP2040, as it makes it much more suitable for new programmers. And one of the advantages of the RP2040 is that it does have good MicroPython support. However, the Arduino RP2040 doesn't have its own MicroPython yet, and the Arduino have said that they're hoping to get Python support available during July 2021. So if you're watching after this, then hopefully that's there already. But in the meantime, you can probably use the standard Pico image, but as it doesn't have support for any of the features of the board, you're kind of like defeating the point of getting this Arduino version. But it sounds like it's going to be well worth waiting for this official version. Hopefully in July I'll be able to revisit this using Python, and I'll also hopefully over the next few weeks or months be able to have a play both using C and using Python. This board is also going to be IoT cloud ready, so that's a feature that Arduino provide, but again that's not ready yet, so that'll allow it to be used in the Arduino IoT cloud ecosystem. And again, that might be something I'll cover in a future video. I also have the Maker Wi-Fi 1010, which is also compatible with the IoT cloud, so I might look at both these in that sort of scenario. In summary, the Arduino Nano RP2040 is a fully loaded microprocessor board based around the Raspberry Pi RP2040. It's significantly more expensive than some of the other boards, particularly the Raspberry Pi Pico, which is much cheaper. And that's obviously one of its main selling points. But for the Arduino Nano RP2040, it really does pack a lot of features into such a small package. It's certainly a good contender for future projects, especially when the MicroPython support is available, hopefully in a month or so's time. So looking forward to getting to use this a bit more and seeing what it's capable of, but looks like it's well worth having a go and having a look at. I hope you found that useful, and if you're interested in following along with other projects I do, I'll be using the Arduino I'll be using RP2040, both the Pico and the Arduino version, and I'm also doing a lot of projects around Raspberry Pi. So please subscribe to my channel if you're interested in any of those, and if you found this video useful, please give it a thumbs up. Let me know anything in the comments, and I hope to see you again on a future video. Thanks for watching.